Good afternoon, everybody, and welcome for the presentation of Technip Energies about hydrogen. I'm Martin van Hoff.
And I'm Stella Chatzisakoula.
And before we entering into the real hydrogen stuff, I would like to tell you something about Technip Energies. Technip Energies is a leading engineering and technology company for the energy transition. We are already there for 60 years, and we are registered here in the Netherlands and headquartered in Paris. We have 15,000 professionals, and we are active in 34 countries. Within the energy transition, we have 4 strategic pillars. We have LNG, sustainable chemistry, carbon-free solutions, which covers green hydrogen, and decarbonization, which is blue hydrogen in there. Our ambition is to grow in technologies, products and services and maintain our position in project delivery. We are a technology and R&D focused company, where decarbonization plays a significant role. And blue and green hydrogen are part of that development. And nowadays, data-centric executions is key in the nowadays project deliveries. And of course, we cannot forget ESG. We have a clear roadmap to net zero project executions.
So Martin gave us a nice introduction about Technip Energies, but today we are here about hydrogen. But why everybody is interested in hydrogen? Here in the slide, you can see a few of the reasons for the significance of hydrogen in energy transition and also in industrial sector. I will highlight a few of them. Energy-wise, hydrogen is a carbon-free, a sustainable element, and it is abundant in the universe. Electrification in energy transition plays a really important role, but we cannot electrify everything. So hydrogen plays really an important role in that aspect to store the electricity that we produce through renewable electricity. Last but not least, to produce power that requires and generates a lot of CO2 emissions. In that aspect as well, hydrogen can also play a role, for instance, with blue power generation with really low carbon intensity. This is a general overview of different pathways towards the production of hydrogen. So depending on the feedstock that it is used, but also on the blocks for technology-wise that are used, we can go and result to different schemes, to different performance, KPIs, but also to different carbon intensities. In this slide, I would like to focus on the resource, on the feedstock that it is used and fed in the system, for instance, natural gas, biofeedstock, and also renewable electricity. Depending on the feedstock, we actually result in a different color of the hydrogen that we produced. For instance, gray, blue, or green.
So let's have a quick poll. We have showed you a number of pathways to produce hydrogen, but which technology do you think will make an impact on the energy transition? It's in the colors. We think it's about green.
With your hands.
Yes, see some hands.
I can see some hands over there.
And we also think blue will play a role.
All right, that's good. That's nice, right? What do you think Technip Energies is working on? What about gray? That's really nice reaction, right? What about blue? All right, good. And what about green? That's really nice. We have some really good news. We're working on all those colors, and today we're going to focus on blue and green.
Perfect. So we have a very extensive heritage in hydrogen and an intensive reference list, which includes also already 50 references of carbon capture or hydrogen plants. But besides that, we are very active and rapidly growing in the green hydrogen. But if we talk about blue hydrogen and blue syngas, we look to it in the sense of building blocks to build the most economic and most efficient scheme. We're using the reformer section, heat integration, shift reaction, carbon capture, and finally the product purification. And if we look to this and we go to a simplified block flow diagram, you see the steps from feed treatment to the product purification. And in between that, we see a number of locations where you do the carbon capture. But carbon capture is not the most important aspect. It's the carbon intensity. I think 2 presentations before, we saw also carbon intensity playing an important role. And yes, that's true. With the technologies and the building blocks within Technip Energies, we can go to very low carbon indexes. And if we zoom in on the reformer section, we do that from SMR to ATR and also a combination of those. And we make those selections based on the design parameters which are given for the project. So not every project will result in the same scheme and the same reforming technology. Also, those technologies have pros and cons, and that's why we always make an assessment of those. If we look, for instance, to ATR utilizing oxygen, and oxygen is produced by an air separation unit. An air separation unit needs a lot of power. And depending on the source of the power, you get a different carbon intensity. So you need to look to the direct emissions and the indirect emissions. If we look to that, then sometimes it's better to go more to the left, complete SMR, or the hybrid configuration, so you're utilizing both technologies. And that's why we look to our projects. So there's not a standardized solution in that sense. But besides the SMR and ATR technologies, we also have to do something with heat. Recuperative reforming has been introduced to utilize the heat to produce more hydrogen instead of utilizing the heat to steam. In the past, and we talk about a couple of decades back, there's a lot of heat generated and not utilized, and there was a lot of steam produced. And during the time, heat integrations, etc., we reduced the carbon intensity of the hydrogen. In the red line, you see the steam production, and by making the efficiency steps, also the steam production goes down. Zooming into blue, Technip Energies delivers blue hydrogen schemes without any export steam. So by applying recuperative reforming, either with ATR, SMR, or the combination of those, we can go to optimum and concentrations of hydrogen out of the plant with the lowest carbon intensities.
Okay, so having said everything about low carbon intensity hydrogen, now it is the moment to focus more on zero carbon emission hydrogen, and in that aspect about green hydrogen. So power to X is quite an important aspect for those applications in order to achieve our energy transition goals for zero carbon emissions. In general, Technip Energies is really active on power to X, but today we will focus on green hydrogen, and this is the main topic of the presentation. For green hydrogen prospects, Technip Energies focuses on two main aspects, the industrial and the utility scale. On the first round, the industrial scale really mainly focuses on the standardization of a green hydrogen production plant. The main topics that are addressed are modularization and optimization of OPEX, CAPEX, but also the footprint area of the whole plant. On the second scale, the utility scale, the main focus and orientation of Technip Energies lies on the whole value chain of the plant. So really starting from the proper and most optimized generation of electricity production through renewable sources, for instance, solar or wind, or the combination of both, towards the end products like hydrogen, or even further to the next step of ammonia and methanol. And that can also be quite effectively used for transportation purposes. Talking about green hydrogen, we cannot skip talking about the electrolyzers. Technip Energies is an engineering company and still remains agnostic when it comes to technology, electrolyzer technology. Here is an overview of the main technologies that are used currently in the markets with different characteristics and different TRL level of maturity. As I said, Technip Energies remains agnostic, and this is quite obvious and quite proven since we have projects currently for both PEM and alkaline, atmospheric and also pressurized electrolyzers. The main selection of the technology that it is used really depends on the location of the projects, on environmental constraints of the project as well, but also on the overall cost and the economics of the plant. Last but not least, I would also like to highlight and not to skip the solid oxide electrolyzer. It is a market under development, and we really keep an eye on that technology as well for future application. And this is mainly due to the high efficiency of that technology. It is important to highlight that Technip Energies is really working on large-scale industrial applications, so TRL level plays quite an important role. Technip Energies, what is our added value in that green hydrogen market? Technip Energies works as a system integrator between the different stakeholders in order to accelerate and progress the realization of those type of projects, power to X projects in industrial scale. Here you can see all the full palette of all the different aspects of our expertise and capabilities. I would just like to highlight a few of them because I have already mentioned quite a lot of them on my speech. First of all, the energy management system. This is a system to utilize to optimize the integration throughout the process. So energy-wise, there is no heat that it is wasted throughout the process. And lastly, we utilize our unique power block in order to define and design the proper solution for production of renewable electricity derived from renewable sources like solar or wind. the combination depends, but the selection depends on the location, of course. In general, Technip Energies promotes a compact and really optimized solution towards renewable systems. For a fast track and cost effectiveness, Technip Energies has developed a standardized solution, a 100 megawatts alkaline pressurized green hydrogen plant. This is based on pressurized technology, and this is a starting point for us for green hydrogen solution to the market. With really great focus on safety, this is our solution to the markets that really facilitates the energy transition. The main reason for standardizing that green hydrogen plant is for us to reduce and minimize the time that is required towards the FEED and for EPC price. And I would also like to have a small teaser for you today. For those that haven't really seen the announcements, the recent announcements, we are really glad and really happy to announce our recent collaboration with John Cockerill. Together, we will form a new company, a new joint force called RELY, and that will help us enable going and accelerate more and more towards green hydrogen, but also Power-to-X projects. We're also really excited to see the long-term strategic move of that collaboration that will help us go to the next generation of electrolyzers.
So we told you a lot about what we do as Technip Energies in the hydrogen field. Already, as mentioned, we do that already over 60 years, and we are a leading technology company in that. Here you see a reference base, what we're currently working on or have accomplished. And please feel free to come to our booth A52 for more information about our technologies and our services. Thank you very much.
Thank you.
We have still some minutes left, so if there's any questions, we're happy to receive. Otherwise, please feel free to come to our booth. Questions? There's one there. Okay.
Hey, thank you for this. I'm Bielenis, CEO of Pauli. How are you agnostic if you are now together with John Cockerill going forward? So basically that's
this is like the 1 million question, right?
No, I have to admit that I just heard this news now.
Yes.
So
that collaboration is an exclusive collaboration. So indeed go to a joint force with John Cockerill, but this is exclusive. So that means that we can go with another electrolyzer company for any specific application. So if, for instance, PEM is more suitable for a specific project, then we will go with a PEM vendor, for instance. And vice versa. John Cockerill can also collaborate with another company for another project. So this is exclusive, but we are joining our forces towards the next step.
Any other questions? Thank you.
Thank you very
I
much.
look forward to meet you on our booth.
Yes.